try and do a cross-category type of synergy as well as collaboration within Sony. One of our activities every year as part of Creative Center is to create a intelligence report, a macro trend and movement intelligence report for the whole of Sony that will help to inform all of these business units about what's happening in the world and kind of trends and movements that we can expect in the mid to long-term future, talking about the next 3 to 5 and maybe even beyond 10 years in the future. What we are looking at really are trends in technology, consumer design, as well as innovation in all these fields to report back and make some recommendations for our colleagues and partners in Sony.
How did it take you to develop the and what was your motivation and object for developing it? Could you tell us the background story?
It started, we as an organization and as a business have put our mission statement very clear and loud, is that we'll be working on waste recovery and energy efficiency solutions as a social responsibility. And since 2017, we have been experimenting when we were addressing the problem of sand reclamation. So I would say this is a balance between social and commerce. To be able to sell a sand reclamation plant, if I am able to build a system which can make them zero discharge, then I have a definite commercial advantage over my competition today. So that thought process of changing the playing ground, and being seen in a different context was important. At the same time, meeting our mission. So that's where it came from. We have been investing in innovation year on year in R&D from our own resources. There is no external funding today for us. It was a calculated risk of using our internal resources. So the entire designing, everything was done internally.
Or whether it had been used in an actual construction project.
It's only a matter of time, Gerald, because I do want to make sure that we have tested it in all aspects before confidently and vocally saying out loud, saying that please go ahead and use this brick wherever you want it. But as of now, I'm confident of placing it on the exteriors. So you can do a lot of landscape elements, you can do pavers, you can do boundary walls. That's where it is at the moment, because we do have confirmation on testing about that, and in terms of in bonding strength and things like that. But when it comes to the interior spaces, I want to do fire tests, I want to do UV tests, I want to do a few of those radiation tests, and then make sure that it's safe, and then sort of promote it. So maybe 6 months down the line, once we've finished our other set of tests, then we can promote it as a good enough, as an equivalent of the regular brick. The unique properties of this particular brick. I mean, the idea of a brick was just a starter. What Mr. Manish and his team have managed to do is that they have been able to fuse carbon dust with plastic as a binder. So what comes out, and once you go through the press kit, there's a video there, and with that machine, they've managed to extrude this paste-like thing, which is moldable, right? So you can create any particular mold, and you can make a finished product. We started with bricks because me being the architect, and it was a natural movement towards that. But we could make something even as finished as probably cell phone covers, for that matter, and it's made with carbon dust. That's the most brilliant part of this innovation, And like when I talk to the architectural fraternity in general, so the possibilities start to become endless. We can look at facade cladding, we can look at or sculptures, we can look at anything, and all of that is coming out of a piece of waste. So there's also different textures you can try on it. You can grind it, cut it, saw it, mill it, route it. So all possibilities tend to open up.
We are now building a Lego type construction with Sridhar in trying to experiment how to make a wall without concrete and without water, cement, and sand.
The good part about the brick is it has some amazing insulating properties. So it actually sets out very well for colder climates.
Could you give us an indication of the cost of one of these SPBs, as you call them, and how it compares with a regular brick?
In the cost, see, there are, before I give the comparison, the cost has two elements. One is the input material we consider as free because it's a waste, since it's zero value. The second element is manpower, which is needed to build. And the third element is energy. The cost of energy is nearly 60%. Okay? So what we are now proposing is to use the solar energy. We are coming up to see that we can make this heating cost zero. The moment we make the heating, at this moment, if we take the energy cost as the electricity, we are at par with the cost of a red brick, the normal clay brick on an average. So a 10 rupees, Indian rupees, 10 rupees is the cost of SPB. A good quality brick may cost anywhere between 8 rupees to 12 rupees, depending on the city, sometimes even more. So I see that the cost is at par with what we have today, but this can become cheaper than the present product with a higher strength and a much lower as-built cost. See, there are three elements. It's not only the component itself, but when you assemble this with lesser cement, lesser water, lesser concrete in faster time, where we can look at the as-built cost. So as a one-on-one today, yes, we are at par with what is available today. The reason why we made this hollow was to make it competitive, because now this brick is 30% to 40% lighter than the red. And the per kg cost has gone down, and still the strength is 2 times.
Are there any disadvantages or downsides to this product?
Yes, it's black in color.
Yeah, one is the color, of course. So architects may not enjoy looking only black. People ask me, can this be of a different color? I said, because the input material is black. At this moment, we don't have a control, but we can look at it. The second probably disadvantage would be the fire resistance level, because of the binding agent being plastic intrinsically. It may not go to that highest level of fire resistance. It may be at a mid-level, so we may not be able to use it to as a load-bearing internal wall, for example. Third is the risk of, connected with this business is you are connected to two wastes, and history says that whenever you are taking any waste as free, the moment it becomes commercial, then you have people sitting over there to make money out of it. And it's very important to ring fence the entire business model. And one of the things which I am doing right now is, because I'm connected with the social space a lot, social entrepreneurship, we are trying to see that this model is not operated by commercial people. Its input cost today does not have a measuring matrix. Right? So some places people have to get money for plastic. Today we are taking plastic at zero cost. What happens if the cost of the plastic goes up? Then the economics change. So there's a risk of economics.
Two of the primary building blocks of this particular material are free. The one is plastic, which is a waste plastic that you see everywhere littered. and the other is dust. But dust again is also limited to boundaries. So there is that element that it's not a universally available material. It's a resultant material that happens to be accumulated more in isolated places where these foundries are set up. But it's a huge amount. That's definitely something to consider. And if that amount is only adding every year, and therefore it needs very quick addressal and some sort of a solution. And it's not something that is prevalent only for India, but this is a worldwide issue.
There is also one more challenge in this which we encountered, and to get access to plastic. See, there are certain plastics which have a recycling value also. They can be recycled, like the PET bottles and this. And it was not possible when we started this. We all said that plastic is a waste and there's so much available, but actually you could not get access to that plastic. And for that, for a couple of months in last year in 2019, September, October, we ran campaigns, went to schools, colleges, societies, set up some bins, and made a lot of noise around for getting plastic. And we were able to get them from one is a hospital who's segregating that biohazardous and other plastics. And there's an engineering organization with whom we had some personal relationships. So they are sending us the plastic. And it's coming on a weekly basis. The municipal corporation who's supposed to have that plastic is unable to manage their plastic well. And though they have access, they have the mandate, they are not our supply chain into what we are doing. So there are going to be challenges when we scale this up, getting access to the plastic in a organized way.
What do you guys think is the viability or feasibility of a solution like yours, or maybe something similar in the future to be mass produced as a construction material?
The way I see this, this has to be a material that what we call as a CSR initiative. So basically, as part of corporate social responsibilities, there is a mandate by the government that every private entity is supposed to spend an X amount of money towards their community or their immediate neighborhood to improve their lives. So the way I see this is that this needs to be embedded as part of that policy. But if the government recognizes this particular brick and it mandates any construction, whether it be government or CSR initiative, to be involving this brick as part of their initiative, then it could end up trying to sort out and scale up or absorb a large amount of use for this particular waste product.
There's also one more thing which has happened post all these articles we published is National Productivity Council, which is a central government body, has approached us and put up this proposal to the Department of Science and Technology from the Government of India to take this as one of the pilot projects to consume the waste plastic, and because there is already an order from the Supreme Court in our country for solid waste management. So there's a law in place. And I have been meeting Pollution Control Board people for the last 4-5 years. And what they say is there is a law, but the moment we enforce the law, the industry will close down because there is no solution available. See, till there's a solution available, you cannot enforce the law and say you can't run the industry. So now, the more this information goes out in the market or in the public domain, that there is a solution available, this solution is viable, then the local municipal bodies can also enforce this as a mandate.
And Sridhar, did you have something to add? What about from the architectural fraternity point of view?
See, as far as the architectural fraternity is concerned, I think I've generally got only positive responses because it just, for the first time, the architect is probably given a solution of a moldable brick, and the thought of that actually just it's crazy. How can you have moldable brick? That means I can make it any shape. I said yes, you can make it any shape you want, provided it's of a certain scale. The project of a certain scale. He's like, can I make circular bricks? I said you can make whatever bricks you want. So it just opens a whole range of possibilities of different kinds of structure. So,
do either of you know the scale of the problem with producing regular clay bricks? Because I understand India produces 200 billion bricks a year. It's the second largest producer in the world. And
yes, but the government is actually putting a ban on that because all of these clay bricks means that you're digging up earth and then you're basically baking them in big ovens, and then it produces greenhouse gases. So it's getting curbed. Like the south of India, the South Indian governments and the administration over there has actually banned bricks. If you want clay bricks over there, it's going to cost you 2 times as much as like the regular aerated concrete blocks. Central India also has taken an initiative, but there's large parts in the north and northwest where it's still prevalent. But in a couple of years, I think the bricks are going to get phased out. As of now, red bricks are more expensive than your fly ash bricks. So there is a phasing of, and all of that has happened in the last years. So eventually, red bricks will get phased out because of its implications on the environment. Because there is a cultural tendency to go towards the red brick, even though the red brick is probably one of the worst bricks possible because it's totally dependent on the soil that you use. If the soil has a lot of microbes and organic waste in it, then you're pretty much doomed because that house is going to start decaying very, very quickly. So there is no consistency, but there is that cultural tendency and a mindset that needs to be fought.
It's not only red clay brick which is soil. There is also a lot of water being used.
There is
I don't have a calculation,
huge amount of fresh water. Fresh water being used to cure these bricks.
While you are making it, while you are building it, and when you are curing it.
The other interesting thing is that in India, when you transport these clay bricks, 2% of those actually get broken in the transition. So while loading it on a truck and offloading it back, 2 to 3% are all broken, and then those broken bricks are then used somewhere else. In this case, nothing will break.
What do you think is interesting creating these new, more eco-friendly construction materials?
Gerald, there's a big differentiation between this and this brick and any other brick. The one that you mentioned, something similar is being done in Assam by a startup company. They are using plastic waste and construction debris and similar stuff. What we are trying to do with this particular brick is there is no anything extra apart from dust, plastic waste, and a little bit of silica. We don't have any concrete. We don't have any debris or fly ash or anything of that sort. So in that sense, this is pure gold of waste. It doesn't have any additives. It doesn't have anything. I've also read about bricks being made from textile fabrics. Like there's this Italian girl who made building block bricks out of waste fabric because Europe has a lot of it. So for me, what's important that it needs to address a larger issue. Like we have mountains of dust, and this pretty much takes 80% of that in one brick, and 20% of plastic. 15% of plastic and 5% of silica. So it's addressing the issue at a very, very strong way, rather than all of those bricks are fine. I think at the end of the day, if we can make use out of our waste material, it's good. But what makes this particular product very different from the rest of them is fact that it attacks the issue at large, straight on.
I had made a rough calculation from my experience of foundry that it's around 4.3 million tons of waste dust available in our country every year. As on
Every year.
And I don't know, probably Sridhar would be able to make a study of how much water we are saving when you're using this brick. There's an immense amount of water which is required.
No, absolutely.
One more important factor about this brick is it's like a hot cake. No, you make the brick in 30 minutes, you are able to use it. Rest of the brick you need 15 days to 1 month inventory. So this is a line process. The moment we get this organized, it can be a fully automatic plant. It can have a lot of automation built in the system where we can increase the production to a different scale.
In India, when you transport these clay bricks, 2% of those actually get broken in the transition. In this case, nothing will break.
Let's go.
You see the red brick and you see this. So throwing only from 1.2 meters height, the red brick is broken.
This
Wonderful demonstration. That's quite a dramatic comparison. So I totally understand your point about the wastage now. Thank you for bringing up those very unique points about bureaucracy in India, and also talking about the problem with the soil. I understand, yes, the production of traditional bricks is a huge problem causing soil erosion and things like that in India.
Yes. Yes.
So I understand Mr. Kothari wanted to share a bit about the production process with his colleague Rajnikant.
Rajnikant, can you walk us through the production process in the plant?
Thank you.
So you can see the plastic which we are getting from the industry. This is the input. So every week we send our tempo on the vehicle to collect the plastic from places 1 or 2 kilometers from us, not very far.
This is the waste plastic from outside. And we crush from this crusher, and after crushing, we are getting like this. This is the crushed plastic. Then we mix with it dust and waste. This is a small mixer. We mix it with dust. Okay. This is the all kind of plastic we are using. And then after we fed it to the extruder. This is the extruder. We are feeding from here. There are several heating elements attached to this, and there is a control over there, heating control. So after that, we are getting this long time from the output. We are weighing that. This is the weighing machine, and then we fed it to this press. This is the press. Then we press it. After that, after removing the press, we are putting in this water just to cool down.
Cool down, and it does not deform. If you don't cool it instantly, it will deform.
This is the final. This is a hollow brick, and this is the paver block. Paver block. So this is the raw material, that plastic.
Sridhar, can you show us the wall which we have made? And we have plastered the wall also. we made our toilet blocks out of our own bricks.
This is the wall we have made from, and this is from conventional brick. This is just to compare with each other.
So a lot of people ask us a question whether this will bond or not. I said I can only show you the wall rather than talking about theory.
And this is plaster.
So I know that Rhino has made the SDGs, the Sustainability Development Goals, its mission, and I also know about the story from how this all started from your client Bricks India to give them a solution to become zero waste. So why do you think this is important for you, and what about for other Indian companies or SMEs? And what do the UN SDGs mean for them?
So probably you might be aware of a research that because I've been listening to a lot of research about SDGs, that our resource efficiency we are consuming 1.7 times of what we should be today. Right? So we are consuming more than what we are supposed to as a population in the world, and so the sustainability of any business, even my business, own business, would be there if there's a business around me. So if I don't look at the community level, then probably I might be missing something about my own business as well. So we are looking from that perspective. Second, every problem is an opportunity and is a business. So there's an agenda put out there by the UN on the SDG. And if we are able to bring a solution to doing something in the waste, it's also a business for us because we'll be producing machines. We'll be selling machines. It's not just we are doing some charity to somebody. It's a transparent system where we are machine builders. Our interest is in setting up plants, not in producing bricks. And we can help people set up these plants and they can produce the bricks and sell. So this is as far as we are concerned. For most of the SMEs and even the larger corporates, and if I'm talking of the foundry industry, today when people from the Western world, US, Europe, or even Japan or Singapore, they are buying castings, they are also looking at the green elements of the supplier. So this is also taken into account when they are in the part of the supply chain of the global value chains. So our customers who are throwing away, who are not disposing their dust, are looking at improving their contribution to the SDG, which can be leveraged into their own business. So it's not only about taking off their waste, but also being part of the global value chain. Because this is also one of the very important factors today. If you are polluting, you are not in the global value chain.
Wonderful. Thank you guys so much. Sridhar, Mr. Kosarami, thank you so much for your time.
Thank you.
It was very inspiring to hear from you guys, and we learned a lot.